Alright, so today we are adding and subtracting one-step equations. So if it tells me that it's a one-step equation, that means that I'm simply just doing one step to solve for x. So most of the equations that we did yesterday, those were two steps because we were having to add or subtract from both sides, and then we also had to divide, right? So that's two steps, adding and dividing. Here we're just doing one-step equations, so it means you're just going to have to do one step before you get to your answer. And we're just doing adding and subtracting, so that means there will be no dividing or multiplying for today's notes. Okay. So as we figured out yesterday, an equation is just a mathematical sentence that contains an equal sign. So if you see a bunch of numbers and operations without an equal sign, what is that called? A what? A number sentence, but what else? If it doesn't have an equal sign. Okay, so we have equations which have equal signs. Carson. A problem. An expression. An expression does not have an equal sign. An equation does have an equal sign. Okay. So we're going to be working with equations, so we should always have equal signs here. And then the value that we find for that variable that makes an equation true is called a solution. So whenever you find x is equal to a number, that's your solution. So when it tells you to solve the problem and check your solution, we're just plugging in x and we're checking that solution. We're seeing if our answer is right. Okay. So let's do a couple of examples. Number 1, we have 25 is equal to y minus 14. So if I'm trying to solve the equation, that means I'm getting y by itself. How can I get y by itself? Casey. Taking away 14. So if I subtract 14, so minus 14 again would give me what? No. If I have negative 14 minus 14, does that give me 0? No. That gives me a negative 28, right? So what if I add 14? Remember, I'm trying to get 14 away, so I have to do the opposite. So this is a negative 14, or subtracting 14, so I have to do the opposite of that to get it away, because I want it to equal 0. So that means I've got to add 14 to both sides. Because then negative 14 plus 14 gives me 0, right? Yeah. So those two cancel out, and it leaves me with a y. But then remember, whatever I do to one side, I have to do to the other side. So if I added 14 to the right, that means I have to add 14 to the left as well. So y equals what? 29. 39. 5 plus 4 is 9. 2 plus 1 is 3. So y equals 39. If I added 14 to both sides, there's a property that states that. Okay. So this is what? No, we don't know this property yet. This is called the addition property of equality. Yes, you need to write this down because you need to know these properties. So it's the addition property of equality because we're adding that number to both sides in order to still have an equal equation, right? So that's why it's called the addition property of equality. So I'm adding 14 to both sides to make my equation equal. So it's addition property of equality. I found out that y equals 39. Am I done yet? I always have to check my equations, right? Whenever I'm solving equations, I always have to check my answer. Even if on the directions it might not say check your answer, you're still checking your answer because you are always checking your answer. So I'm plugging it into my original equation. My original equation is 25 equals y minus 14. So then I'm just plugging 39 in for y. So that means I have 25 equals 39 minus 14. And I'm trying to see if my right-hand side is truly equal to 25 like it says it is. Okay. So what is 39 minus 14? 25. Is 25 equal to 25? Yes. So my answer is correct. Does anybody have questions on number 1? So this is similar to what we did yesterday. It's just one step less. Okay. All right, number 2. I've got 67 equals m minus 29. So if I'm trying to solve for m, that means I've got to have m by itself. So how can I do that? Jaden? To both sides, right? So I'm adding 29 to both sides. What does 67 plus 29 give me?
96.
So I have 96 equals m, right? Because my negative 29 and my positive 29 cancel out. They give me 0. So m equals 96, and then I want to check it, make sure I did everything right. So if I have 67 equals m minus 29, I'm just plugging it in. So I have 67 equals 96 minus 29. What is 96 minus 29? 67. Is that equal to 67? Yes. My answer is correct. X, or m, is equal to 96. Questions on number 2? All right, what about number 3? We've got fractions now. But everything still stays the same. We're just dealing with fractions. So if I've got d minus 1/3 and I want to get d by itself, what do? I add 1/3. I'm still using that addition property of equality. So my negative 1/3 and my positive 1/3, they give me 0, so they cancel out. And then I have 1/6 plus 1/3. How do I add fractions? I've got to find that common denominator first. So what is my common denominator? 6 is my common denominator, right? So that means I've got to multiply my second fraction by 2. So that gives me 1/6 plus 2/6. What is 1/6 plus 2/6? 3/6, which equals 1/2. So D equals 1/2. Can y'all see that okay? Big enough. So if I want to check my answer, I'm just plugging it in. So D is 1/2, so I have 1/2 minus 1/3, which equals 1/6. If I'm subtracting these fractions now, I've still got to find a what? Common denominator. So I'm going to multiply by 3 on my first fraction and by 2 on my second fraction. So that gives me 3/6 minus 2/6. What is 3/6 minus 2/6? 1/6. 1/6 equal to 1/6? Yep. So my answer is correct. So even though I'm working with fractions, it's still the same exact thing. Okay? This is why it's so important that we remember how to add, subtract, multiply, and divide those fractions. We're never going to get away from that. Questions on number 3? All right, number 4, I've got x plus 24 equals 72. So I'm trying to solve for x. So what do I need to do? Subtract 24 from both sides. All right, so in 1 through 3, I added both sides, right, to keep equality. And that was the addition property of equality. So what do we think this property is called? Subtraction property of equality. Good. So it should be pretty easy to remember. Whatever you're doing to that one side of the, or both sides of the equation to make it equal again, that's what the name of the property is. So if you're adding to both sides, then it's the addition property. If you're subtracting from both sides, it's the subtraction property. Okay. So once I subtract, 24 minus 24 gives me 0. So that leaves me with x on the left-hand side, and then what's 72 minus 24? 48. So x equals 48. And then I want to check it. So I'm plugging it in. 48 plus 24, does it equal 72? What is 48 plus 24? 72. So I worked it all right. My answer is correct. Sorry, can y'all see that? Questions on number 4. Alright, number 5, I've got P minus 13 equals negative 45. I'm solving for P. So what am I doing?
Adding 13 to both sides.
To both sides. Good. So my negative 13 and my positive 13 cancel out, just leaving me with a P. Then I have negative 45 plus 13. Before we solve it, what is my answer going to be, negative or positive?
Negative.
Negative, because 45 is larger. Okay. So let's see about solving this in our calculator, because we can use our calculators now. This is something that we need to be careful with when we're doing negatives. Okay. If you look at your calculator, you've got a negative button down here. Your negative button is different than your subtraction button. So if you're plugging in a negative number, be sure that you're hitting the negative button and not the subtraction button. Okay. So if I want to do negative 45, I'm going to plug in negative 45 plus 13, which gives me negative 32. The negative 32 is my answer for P. So be sure that you're using that negative button and not your subtraction button. And then I want to check it. So how do I check it?
P minus 13 equals negative 45. And then you plug in negative 32 plus negative 13. And you get negative 45.
Good. So all you're doing is plugging it in. So if I'm subtracting 13 from negative 32, it indeed gives me negative 45. So it checks out. Questions on number 5? Good? Alright, flip it over. Alright, number 6, I've got x minus 32 equals negative 2. How am I solving for x?
Plus 36 on both sides.
I have to do the opposite, which is adding. So 36, adding 36 to both sides.
And then you get, and you cross out negative 36 plus 36 is gives you 0. And negative 2 plus 36 is 34.
Good. So x equals 34. And then I want to check it, right? So I have x minus 36 equals negative 2. So then I'm plugging it in. So 34 minus 36 equals negative 2. What is 34 minus 36? Negative 2. So it checks out. Number 7, we've got decimals, but our steps are still the same. So if I have 0.53 plus A equals 1.97, am I adding or subtracting 0.53?
Subtracting.
Subtracting from both sides. So those two cancel out, which leaves me with A on the left-hand side, which is equal to what?
1.44.
1.44. So when I check it, I'm plugging it in. So 0.53 plus 1.44. What is 0.53 plus 1.44? 1.97. Questions on decimals? All right, what about number 8? I've got a mixed number and a fraction. So, okay, I need to subtract 5/8 on both sides, but do I want to keep that mixed number, or do I want to go ahead and change it to an improper fraction? Let's go ahead and change it. So that means I've got 1 times 4 plus 3. So that gives me what? A fraction. 7 over 4, which equals B plus 5/8. And then Nick said we need to subtract that 5/8 from both sides. So I know that leaves me with B on the left or on the right hand side. But then I need to actually subtract my two fractions. So if I subtract 7/4 and 5/8, I've got to find that common denominator, which is 8, right? So I want to multiply my first fraction by 2. Okay, it gives me 14 over 8 minus 5 over 8, which gives me what? 9. 9 over 8, which equals 1 and 1/8. So over here for B, I'm going to put both of those answers. So 1 and 1/8 or 9/8. Because if I'm checking my answer, don't you think it's going to be a little bit easier to go ahead and use that improper fraction instead of the mixed number? Yeah. So when I'm plugging it in, I'm going to go ahead and use the equation when I went ahead and changed it to an improper fraction, so that I don't have to change it again. So I've got 7/4 equals B plus 5 over 8. And then I'm going to plug in 9/8 for B. So I've got 7/4 equals 9/8 plus 5/8. What is 9/8 plus 5/8? Keep messing up. 14/8. Is 7 over 4 equal to 14 over 8?
Yes.
Yes, because I can simplify 14 over 8, right? Which simplifies to 7 over 4. Is that right? So it checks out. Anybody have any questions? Are we all good? Okay. Last one. Number 9. I've got A plus 5.7 equals 9.2. So what property do I need to use in order to solve for A? A subtraction property of equality. So that means I'm subtracting 5.7 from both sides. So my positive 5/7 and my negative 5/7 cancel out. And that leaves me with what? 3.5. So A equals 3.5. And then I want to check it. So that means I'm plugging in 3.5 for A. What is 3.5 plus 5.7? So my answer is correct. I'm going to look at one problem in our book from your homework so that you know how to do it, okay? So our homework today is page 189, 12 through 36. So let's look at number 29. So I've got e minus negative 36, which equals negative 5. I'm still solving the equation and checking my answer. Okay. So e is my variable here. How do I need to simplify this first so I know what to do to both sides? Good. These two negatives right beside each other, they make a positive. So I need to go ahead and rewrite this as e plus 36, which equals negative 5. Okay. So we're going to have to use all of our integer rules whenever we're solving equations. So I have e plus 36 equals negative 5. So if I'm solving for e, I've got to subtract 36 from both sides, right? So that gives me e is equal to what? What's negative 5 minus 36? Negative 41. So on all those down there, if you see two negatives beside each other, you need to know that you've got to change that to a positive. Let's look at number 31 as well. And then the rest are going to be on your own. You should be able to do the rest. So 31, I've got negative 2.5 plus g equals negative 1.3 plus negative 1.1. So I'm still solving for g, but I need to combine my like terms first. Okay. So instead of adding, which you can do this, it's okay. If you wanted to add 1.3 to both sides and then 1.1 to both sides, you can. But I think it's going to be a little bit easier if you go ahead and combine these in one step. Okay. So negative 2.5 plus g equals, I'm going to go ahead and add those two numbers together. So I've got negative 1.3 plus negative 1.1, which gives me negative 2.4. Okay. And then I still need to solve for g. So if I'm getting g by itself, I have a negative 2.5. So what's the opposite of negative? Positive. So that means I'm going to be adding. Okay, so I want to add 2.5 to both sides. So my negative 2.5 and my positives cancel. So that leaves me with g, which is equal to negative 2.4 plus 2.5, which gives me 0.1. Okay. 2.
12 through 26, do we need to do it on the number line?
No, you do not have to graph it on a number line. I think y'all know how to do that already. You're just plotting a point on that number line, whatever your answer is. So you do not have to do that.
Wait, so number 1 through 9, we don't have to do that? No.
You're doing just numbers 12 through 36 for homework.
Oh.
but you do not have to draw the number lines.
How do you know, like, whenever it's like 2.5 plus 3, how do you know you have to, like what number to subtract?
So, right here?
No, where you add 2.5 to both sides, how do you know, like, to add 2.5 to that number?
Because you're trying to solve for G, so that means you're getting G by itself. So, that's why you have to get rid of the other number that G is with. Does that make sense? Because you're trying to get G completely by itself.
So whatever the variable is with, that number?
Yes, you want to move that number that's on the side of the variable to the other side. Okay. Any other questions? All right, let's get started on homework. It is page 189, 12 through 36 off.